Hello, in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle. We know that PA equals to 6 units in its length, and PA is also tangent to the semicircle at point A. We also know that line segment PQ equals to 4 units in its length, and line segment PS cuts the semicircle at points Q and S, and we also know that QC equals to QS. This angle PAB equals to 90 degrees. This is angle SQC. This is also equals to 90 degrees in its size. Our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. We have here rule number 10. According to rule number 10, rule number 10 is true in any circle. So in any circle, if chord if AB is any chord in the circle, here AB is a chord in the circle, and we also know that PT is tangent to the circle at point T. Then the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because if you focus at point P, from point P we have tangent PA that is tangent to the semicircle at point A, and we have also line segment PS that cuts the semicircle at points Q and S. For that reason, we can implement here rule number 10. Okay, so here, according to rule number 10, PA square equals to PQ times PS. Repeat again. According to rule number 10, in our drawing, PA square equals to PQ times PS. PA is 6, therefore PA squared is 6 squared, that is 36. And it is equals to PQ is 4 times PS. PS in total equals to 4 plus QS. So actually we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we'll divide this equation by 4, and finally we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and finally we get that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. This line segment QX equals to 5 units in its length. But it is given us the equation that QS equals to QC, and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, we'll join points P and C together by a straight line. And we will focus on the lower side of the straight line PS at point Q. And in the lower side of the straight line PS at point Q, the sum of the angles must be equal to 180 degrees according to rule number 3. I repeat again on rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have here the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule number 3. So which angles we have at the upper side of AB at point Q? We have here angle alpha and angle beta. So according to this rule number 3, alpha plus beta must be equal to 180 degrees. Actually, we can implement rule number 3 in our drawing. Why? Because if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. And therefore, triangle PQC is a right triangle. So I'll copy the right triangle PQC in a new page and we will implement the Pythagoras theorem on this right triangle, triangle PQC. Here by PT is the abbreviation for Pythagoras theorem. Side QC equals to 5 units and PQ equals to 4 units according to what is given as the question. Actually, this is the right triangle, triangle PQC that I copied from the original drawing. In this right triangle PQC, according to the Pythagoras theorem, we will get that PC square, that is the square of the hypotenuse, equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total we found out actually that PC square equals to 16 plus 25, that is 41. The square of the hypotenuse PC square equals to 41. In the next step, I will copy the right triangle, triangle PAC in the new page, and we will implement on this right triangle, triangle PAC, the Pythagoras theorem. PA equals to 6 units according to what is given as the question. PC square equals to 41. So actually, this is the right triangle PAC that I covered from the original drawing. We define the length of side AC as A. We already found out that PC squared, that is the square of the hypotenuse, equals to 41. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in the right triangle PAC, we will get that PC squared equals to PA squared plus AC squared. PC squared is 41 and it is equal to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. AC is A according to the definition, therefore AC squared is A squared. In total, we found out actually that 41 equals to 36 plus A squared. Here we subtract 36 from this equation and we get that 41 minus 36 is 5, so 5 equals to A squared. Here we take a root out of this equation and finally we get that A equals to the square root of 5 units. A equals to the square root of 5 units. So we can write here that AC is equal to A according to our definition is equals to the square root of 5 units. What is the length of CB? What is the length of line segment CB? From the drawings it's very easy to see that CB equals to AB minus AC. Because of the fact that this is a semicircle, AB must be the diameter of the semicircle. So if we define the radius of this semicircle as x, then the diameter AB must be equal to 2x. So AB equals to 2x, AC equals to square root of 5, and CB in total equals to AB minus AC. That is to say CB equals to AB, that is 2x, minus AB minus AC, that is square root of 5. So in total CB equals to 2x minus square root of 5 units. So I write it down. CB equals to 2x, that is the diameter of the semicircle, minus AC, that is square root of 5 units. Right here also that CB equals to AB minus AC. AB is 2x, AC is square root of 5, so in total CB equals to 2x minus square root of 5 units in its length. Okay. In the next step, we'll complete the semicircle to a circle. So we completed the semicircle to a circle. And you will extend side QC by straight line until it touches the circle. We will define the touching point of the extended side QC with this circle as M. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 11. According to the new rule talks about two chords that intersect with each other inside the circle. Here we have chord AB that intersects with chord DC at point O. Whenever you have two chords that intersect with each other, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. So I write it down. Chord AB intersects with chord QM at point C. Repeat again. In our drawing, we have chord AB that intersects with chord QM at point C. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. Here we define the length of line segment CM as B. Repeat again, according to rule number 11, we get that AC times CB equals to QC times CM. AC equals to the square root of 5. This will be equation number 1. Times CB. CB equals to 2x 1 square root of 5. And it is equals to QC. QC is 5. Times CM. CM is B. So we conclude further that according to rule number 11, 5 times 2x minus square root of 5 equals to 5b. Here we divide this equation number 1 by square root of 5. And finally we get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. So here we will add to this equation number 1 square root of 5. And we'll get that 2x equals to 5b over square root of 5 plus square root of 5. Here we multiply square root of 5 by square root of 5, and then we divide it by square root of 5 in order to have a common factor with this expression. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus, we'll multiply square root of 5 by square root of 5 and then we'll divide it by square root of 5. So we change nothing. So in conclusion, we found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 over square root of 5. So that is to say, according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. Here we'll divide this equation number 1 by 2, and finally we will get that x, that is the radius of the semicircle, the radius that we are looking for, x equals to 5b plus 5 over 2 times square root of 5. So in order to find out the value of x in numbers, we have to find out the value of b, that is actually the length of line segment AC. Okay. In the next step, we'll join points M and S together by a straight line. So in the drawing we have peripheral angle MQS. This is peripheral angle MQS. This peripheral angle MQS equals to 90 degrees. I'll write it down. Peripheral angle MQS equals to 90 degrees in its size. And we have here rule number 5 that talks about peripheral angles that are equal to 90 degrees in their sizes. According to this rule number 5, any peripheral angle that is equal to 90 degrees, and again, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees, and therefore, according to this rule number 5, this peripheral angle must rest on the diameter of the circle. Peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. You can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. Peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle according to rule number 5. So you can write here that according to rule number 5, MS must be the diameter of the circle. The diameter of the circle and also the diameter of the semicircle, the diameter of the circle. Okay, and we know that the radius of the circle is x, therefore the diameter must be equal to 2x. So the diameter MS must be equal to 2x. In the next step, I will copy the right triangle MQS in a new page, and we will implement on this right triangle MQS the Pythagoras theorem. Repeat again that by PT is the abbreviation for Pythagoras theorem. side QS equals to 5 units in its length. What is the length of QM? Side QM equals to 5 plus B. Again, QM equals to 5 plus B. And the hypotenuse MS is the diameter of the circle, that is equal to 2x. So actually, this is the right triangle QMS is the copy from the original drawing. By PT is the version from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle QMS, we will get that MS squared equals to QS squared plus QM squared. This is equation number 2. So MS is the hypotenuse that is 2x, therefore MS squared is 2x squared. That is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. So this is equation number 2. 2x squared equals to 25 plus 5 plus B squared. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So therefore we can actually substitute x in this equation number 2 by the value of x in equation number 1. According to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. So we can substitute x in this equation number 2 by 5b plus 5 over 2 times square root of 5. So we'll do it now, and we'll get that according to equation number 2, we have 2 times x, and x according to equation number 1 equals to 5b plus 5 over 2 times square root of 5. So it is 2x squared. According to equation number 1, according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. So I repeat again. In equation number 2 we have 2x squared. So we substitute x in equation number 2 here by 5b plus 5 over 2 times square root of 5. So this expression in total equals to 2x squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in this side of the equation we left only with 5b plus 5 squared over square root of 5 squared is 5, and it is equal to 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is 10b. So here we'll open the brackets on this side of equation number 2, and we get that 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b, all divided by 5, and it is equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have, in this side of the equation number 2, we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, and 50b over 5 is 10b. This side, in this side of the equation, in the other side of the equation, we have 10b plus b squared plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of equation number 2, after we cancel 10b, we left only with 5b squared plus 5 equals to, in the other side of the equation, we left only with b squared plus 50. So here we subtract b squared from this equation, equation number 2, and we get that according to equation number 2, 5b squared minus b squared is 4b squared, plus 5 equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45. Here we divide this equation, equation number 2 by 4, and finally we get that according to equation number 2, b squared equals to 45 over 4. So b squared equals to 45. We substitute 45 by 9 times 5 over 4. Here we'll take a root out of this equation, equation number 2, and finally we'll get that according to equation number 2, b equals to the square root of 9 times 5 over 4. Repeat again, actually found out that according to equation number 2, according to equation number 2, b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3, and the square root of 4 is 2. Inside the root we left only with 5. In conclusion, found out actually that b equals to 3 times square root of 5 over 2. This is according to equation number 2. Well, according to equation number 1, we have already found out that x equals to (5b plus 5) over 2 times square root of 5. So now we can substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. We'll do it now, and we get that according to equation number 1, x is the radius that we are looking for, the radius of the semicircle x equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So actually we found out that according to equation number 1, x equals to 5 times 3 is 15, so in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So x equals to, here we'll multiply 5 by 2 and then we'll divide it by 2 in order to overcome factor with this expression. And we get that x equals to 15 times square root of 5 over 2, and 5 times 2 is 10. So we multiply it by 2 and then we divide it by 2, so we change nothing. All divided by 2 times square root of 5. So here we will move 2 times square root of 5 to the denominator here, and we get that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So in conclusion, found out actually that x equals to 15 times square root of 5 plus 10 over 2 times 2 is 4, so in the denominator in total we have 4 times square root of 5. Repeat again, actually we found out that x, it is the radius that we are looking for, it is equals to 15 times square root of 5 plus 10 over 4 times square root of 5. So x equals to square root of 5 times 15 plus 10. We substitute 10 by 2 times square root of 5 times square root of 5. All divided by square root of 5 times 4. In the next step, we take square root of 5 as a common factor from those two expressions, and we get that x equals to the square root of 5 is a common factor. So what is left from square root of 5 times 15 until we took from it square root of 5 is a common factor? What is left is actually 15 plus what is left from 2 times square root of 5 times square root of 5 after we took from it square root of 5 is a common factor. What is left is actually 2 times square root of 5, all divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that x, that is the radius of the semicircle, equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, x, that is the radius of the semicircle, that is the radius that we are looking for, is equals to 4.8680 units. And that is the answer to our question. In the next step, I will summarize the lecture. In this lecture, we found out the radius of this semicircle. In the drawing, we have line segment PA equals to 6 units in its length, and PA is also tangent to the semicircle at point A. Line segment PQ equals to 4 units in its length, and line segment PS cuts the semicircle at points Q and S. In addition, we also know that QC equals to QS. This angle is angle PAB that is equal to 90 degrees, and this is angle SQC that is also equal to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. Okay, so first of all, I presented to you a new rule. and we implemented the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is a chord in the circle and PT is a tangent to the circle, then the following equation is true, that is to say PT square equals to PA times PB. Again, here we have tangent PT is tangent to the circle, that's point T. AB is a chord in the circle. So here we get that according to this rule, rule number 10, PT square equals to PA times PB. Again, PT square equals to PA times PB. Can implement rule number 10 in our drawing. Why? Because in our drawing, if you focus on point P, from point P we have tangent PA to the semicircle, and we have also line segment PS that cuts the circle at points that cuts the semicircle at point Q and S. Therefore, we can implement here rule number 10. According to rule number 10, we get that PA square equals to PQ times PS. So repeat again. According to rule number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ, that is 4 times PS. PS, in total, PS equals to 4 plus QS. Okay? PS equals to 4 plus QS. Here, PS equals to 4 plus QS. So in conclusion, we found out that 36 equals to 4 times 4 plus QS. Here we divided this equation by 4. And finally found out that 36 over 4 is 9. So 9 equals to 4 plus QS. Here we subtracted 4 from this equation. And finally we found out that QS equals to 4 minus 9, that is 5. Here, this line segment QS equals to 5 units in its length. But because of the fact that it is given us the equation that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, we join points P and C together by a straight line, and then we focused on the lower side of the straight line PS at point Q. At the lower side of PS at point Q, the sum of the angles must be equal to 180 degrees according to rule number 3. Repeat on rule number 3 again. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have the straight line AB. If you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and beta. According to this rule, rule number 3, alpha plus beta must be equal to 180 degrees. Actually, we can implement rule number 3 in our drawing. Why? Because in our drawing, if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. If this angle equals to 90 degrees, it means that triangle PQC is a right angle. So I copied the right triangle PQC in the new page and we implemented on this right triangle PQC the Pythagoras theorem. So actually, this is the right triangle PQC that I copied from the original domain. PQ equals to 4 units according to what is given us in the question. We just right now found that QC equals to 5 units. So in the right triangle PQC, according to the Pythagoras theorem, PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC squared is 5 squared, that is 25. So in total we actually found out that PC squared equals to 16 plus 25, that is 41. So in conclusion, we found out that PC squared, that is the square of the hypotenuse, equals to 41. Then I copied the right triangle PAC in a new page and we implemented the Pythagoras theorem in this right triangle, triangle PAC. So actually this is the right triangle, triangle PAC that I copied from the original drawing. PA equals to 6 units according to what is given as the equation. We define the length of side AC as A. So according to the, and we know that PC squared equals to 41. So according to the Pythagoras theorem, in this right triangle PAC, we get that PC squared equals to PA squared plus AC squared. PC squared is 41, and it is equals to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. AC is 8, therefore AC squared is 8 squared. So in conclusion, we found out that 41 equals to 36 plus A squared. Here we substituted 36 from this equation, and finally we found out that A squared equals to 41 minus 36 is 5. So A squared equals to 5. We took out of this equation and finally found out that A equals to the square root of 5 units. 97 AC or side AC that is equal to A, it is equal to square root of 5 units. Here we can write down in the original drawing that AC that is equal to A, it is equal to the square root of 5 units. Because of the fact that this is a semicircle, AB must be the diameter of the semicircle. So AB, so if we define the radius of this semicircle as x, then the diameter AB must be equal to 2x. Okay, if the radius is x, then AB is 2x. Here, x is the radius, therefore AB, the diameter AB is 2x. What is the length of CB? From the drawing it is very easy to see that CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is square root of 5. So in total CB equals to 2x minus square root of 5. Repeat again, CB equals to AB minus AC. AB is 2x and AC is square root of 5. So in total CB equals to 2x minus square root of 5. Then I completed the semicircle to a circle, and we extended side QC by side line until it touches the circle at point M. Then I presented to you a new rule and we implemented the new rule in our drawing. This is actually rule number 11. According to rule number 11, rule number 11 is true in any circle. Rule number 11 talks about two chords that intersect with each other inside the circle. So here, if chord AB intersects with chord CD or DC at point O, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Repeat again. In our drawing we have chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we'll get that AC times CB equals to QC times CM. I repeat again. According to rule number 11, in our drawing, we get that AC times CB equals to QC times CM. AC is square root of 5, CB is 2x minus square root of 5, QC is 5, and CM is B. CM is B according to our definition. Here we define the length of side CM as B. So CM is B. So in conclusion, we found out that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we divided this equation number 1 by square root of 5. And finally, we found out that 2x 1 square root of 5 equals to 5b over square root of 5. Then we added to this equation number 1 square root of 5, and finally we found out that 2x equals to 5b over square root of 5 plus square root of 5. Okay. Then we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to overcome a factor with this expression. And finally we found out that 2x equals to 5b over square root of 5. Here we multiply square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. So in conclusion we found out that 2x equals to, in the numerator, 5b plus square root of 5 times square root of 5 is 5 over square root of 5. Then we divided this equation number 1 by 2, and finally we found out that x equals to 5b plus 5 over 2 times square root of 5. Okay, then we joined points M and S together by a straight line. So in the drawing we have here peripheral angle MQS that is equal to 90 degrees. And we have here rule number 5 about peripheral angles that are equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have in the drawing peripheral angle MAN that is equal to 90 degrees. Therefore this peripheral angle must rest on the diameter of the circle. Peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. We can implement rule number 5 in our drawing. Why? Because in our drawing we have also peripheral angle that is equal to 90 degrees. This peripheral angle MQS equals to 90 degrees. Therefore, according to rule number 5, this peripheral angle must rest on the diameter of the circle. This peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle. I repeat again, because of the fact that peripheral angle MQS is equal to 90 degrees, therefore must rest on the diameter of the circle. Peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle. The radius is x, therefore the diameter MS must be equal to 2x. Repeat again. The diameter MS is 2x. Then I copied the right triangle QSM in a new page, and we implemented on this right triangle QMS the Pythagoras theorem. Again, the hypotenuse MS is equal to the diameter, that is 2x, QS equals to 5, and QM, in total QM equals to 5 plus B. So this is actually the right triangle MQS is the covered from the original domain. Again, QS equals to 5, QM in total equals to 5 plus B, and the hypotenuse MS is the diameter of the circle that is equal to 2x. According to the Pythagoras theorem, in this right triangle QMS, SM square equals to QS square plus QM square. So SM is 2x, therefore SM square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So in conclusion, according to equation number 2, we found out actually the 2x square equals to 25 plus 5 plus B square. Well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Okay, now we can substitute x in this equation number 2 by 5b plus 5 over 2 times square root of 5. We actually did it, and we found out that according to equation number 2, and x is 5b plus 5 over 2 times square root of 5, according to equation number 1, squared, because it is 2x squared, that is equal to 25 plus 5 plus b squared, according to equation number 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, we left here with 5b plus 5 square over square root of 5 square. Square root of 5 square is 5. So in this side of the equation, in total, we left with 5b plus 5 square over 5. In the other side of the equation, we have 25 plus 5 plus b square, 5. So it is 25, and 5 plus b square equals to 5 square, that is 25, plus b square plus 2 times 5b, that is 10b. Then we open the brackets on this side of equation number 2 and finally found out that according to equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, 10b times 5 is 50b, all divided by 5, and it equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. So actually found out that 5, according to equation number 2, 5b squared plus 5 plus 10b equals to 10b plus b squared plus 50. Here we have 10b on both sides of the equation, so 10b we had cancelled. After we cancel 10b, in this side of the equation we left only with 5b squared plus 5. On the other side of the equation we left with b squared plus 50. So in conclusion, according to equation number 2, we found out actually that 5b squared plus 5 equals to b squared plus 50. Here we subtracted b squared from this equation, and finally we found out that 5b squared minus b squared is 4b squared plus 5 equals to 50. Here we subtracted 5 from this equation, equation number 2, and finally we found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. We divided this equation, equation number 2, by 4, and finally found out that b squared equals to 45 over 4. So b squared equals to 45. We substitute 45 by 9 times 5 divided by 4. Then we took a root out of this equation, equation number 2, and finally we found out that according to equation number 2, b equals to the square root of 9 times 5 over 2. The square root of 9 is 3 and the square root of 4 is 2. So we left only with 5 inside the root. So in conclusion, we found out actually that according to equation number 2, b equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So now we can substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. We did it, and we got that according to equation number 1, that x equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. This is the value of x. So here we have 5 times 3 is 15. So in total, this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here x equals to 15 times square root of 5 over 2 plus 5, all divided by 2 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to overcome a factor with this expression, and finally found out that x equals to 15 times square root of 5 over 2. 5 times 2 is 10. We multiplied 5 by 2 and then we divided by 2, so we changed nothing. All divided by 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator here, and finally we found out that actually that x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. 2 times 2 is 4, so in total in the denominator we have 4 times square root of 5. Okay, again, actually found out actually that x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. So x equals to square root of 5 times 15. We substitute 10 by 2 times square root of 5 times square root of 5 divided by 4 times square root of 5. Then we took square root of 5 as a common factor from those two expressions. So what is left from square root of 5 times 15 after we took from it square root of 5 as a common factor? What is left is actually 15. What is left from 2 times square root of 5 times square root of 5, after we took from it square root of 5 as a common factor. What is left is actually 2 times square root of 5, all divided by 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out actually that x, that is the radius of the semicircle, that is the radius that we are looking for, equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius of the semicircle x equals to 4.8680 units. Okay? Thank you very much.